I'm going to go through the answers to the questions that we did yesterday. So in each of these reactions, you are dehydrating an alcohol using a concentrated acid, and that's going to give you an alkene. Because you're dehydrating an alcohol, you are losing H2O. And to lose H2O, you need to lose an OH from one carbon, and you need to lose a hydrogen from an adjacent carbon. Okay, so there are two different carbons. One's losing OH, one is losing hydrogen, and it has to be adjacent. Now, the carbon that's going to lose the OH is easy to spot, okay? This carbon is bonded to the OH, so this carbon is going to lose the OH. And by adjacent, I just mean the carbon that this carbon is bonded to. So if we look at this example, you can see that this carbon is actually bonded to two other carbons. It's bonded to this carbon up here, and it's bonded to this carbon down here. So which one of these is my adjacent carbon that's going to lose a hydrogen? Well, in this case, both of these carbons have a hydrogen. Okay, there's a hydrogen here, and there are two hydrogens down here. So because both of your adjacent carbons contain hydrogen, either one of those could lose the hydrogen along with the OH when it's losing water. That means you're going to have two products, not just one. So if I focus here on this carbon, which I'm going to put a star next to, okay, let's assume that this carbon is losing the hydrogen. What product am I going to form? I'm going to draw it out the same way I had before. I know this carbon here is losing the OH. If this carbon is losing the hydrogen, then it's these two carbons that are each losing a bond. So it's these two carbons that the double bond is going to form between. If I now focus on the second adjacent carbon, okay, which also contains hydrogens, if this carbon were to lose a hydrogen, then the product you are going to get formed is different. Okay, it's still going to be this carbon losing the OH, but if this carbon were to lose a hydrogen, then the double bond would then form this way instead. So you've got two different products, depending on which of the adjacent carbons lost a hydrogen. If we look at the next example, okay, so this clearly is the carbon that's bonded to the OH, so this carbon is going to lose an OH. And again, this carbon has two adjacent carbons. And again, each of these carbons is bonded to hydrogens. If I take this carbon on the left, if this carbon on the left were to lose a hydrogen, then the product you're going to get formed will be, okay, because this carbon is losing a bond, and if this carbon is losing the OH, then the double bond will form here. But similarly, this adjacent carbon could lose a hydrogen. And if that's the case, then you're going to get the double bond forming between this carbon, and this will be your product. In the next example, okay, I've got this carbon bonded to the OH, it's going to lose the OH, and in this case, this carbon is only bonded to one other carbon. Because it's only bonded to one other carbon, you're only going to have one product, okay, it's the only option. This carbon will lose the OH, this carbon will lose the hydrogen, and you're going to end up with this as your product, okay? Be careful that you don't draw an extra carbon in your product by mistake. Our original reactant has 1, 2, 3, 4 carbons. Our product should only have 1, 2, 3, 4 carbons. It's very easy to add an extra line and draw the double bond up here instead. If we look at the next example, okay, this is my carbon bonded to the OH. So this carbon is going to lose an OH. One of the carbons adjacent, and I've got two of them, is going to lose a hydrogen. This carbon is bonded to two hydrogens, but this carbon here isn't bonded to any hydrogens. This adjacent carbon doesn't have a hydrogen to lose, therefore it's not going to be one of your products. There's only one adjacent carbon that actually has hydrogens, therefore, even though you've got two carbons, you're only going to have one product. And your product is going to look like this, okay? You can't have a double bond formed between these two carbons because you've got no hydrogen to lose here. And if you did draw that product, this carbon would end up with 5 bonds. In question number 5, okay, This is your carbon bonded to the OH. This carbon is only bonded to one other carbon, and this adjacent carbon does have a hydrogen. So you're only going to have one product, and that product is going to be as such. Okay, so this carbon is losing an OH, this carbon is losing a hydrogen. Draw the double bond between them. In question 6, this is your OH. So this is the carbon that's bonded to the OH. This carbon is bonded to two other carbons. But if I look at the carbons, this one up here at the top does not have any hydrogens. This carbon down here does have hydrogens. So again, even though we've got two adjacent carbons, we're only forming one product, as only one of the adjacent carbons actually has a hydrogen to lose. And your only product is going to be... Okay, so it helps to draw out the two carbons that you're drawing the double bond between. So if I draw in my carbon here that's bonded to the OH and draw in my carbon here that's going to lose the hydrogen, I know where to put the double bond in my product. Again, in this one, some of you were drawing your double bond out here, okay? So it's on your reactant, just mark the two carbons that are losing something, and then you'll know exactly where to put your double bond in your product, okay? Again, this carbon doesn't have a hydrogen to lose, so you're not going to be forming a double bond along here. If you do, this carbon will have 5 bonds. The last example, I asked you why it can't be dehydrated, okay? So we've got a carbon bonded to an OH, so this carbon can lose an OH, but if I look at the carbon adjacent, it doesn't have a hydrogen to lose. Okay, it's just bonded to other carbons without a hydrogen to lose. It cannot be dehydrated. So I would write that the adjacent carbon does not have a hydrogen atom. Some of you in your answers told me that it was bonded to 2 methyl groups. Yes, that's true, but the important part is to mention it doesn't have a hydrogen. Remember, you're trying to lose water. You're losing an OH. To make water, you need to lose a hydrogen. To mention that you don't have a hydrogen to lose from the adjacent carbon. If you've got any questions about any of this, okay, just message me. I will give you some more of these to practice over Easter in your homework.